So what's going on here? As you might be able to tell, I'm taking an online number typing test without my keyboard. By simply tapping my fingers on my desk in a specific fashion, my computer is able to recognize those taps as numbers. I currently have this device set up such that these taps correspond to these numbers, but this device can be configured so that any tap-like motion corresponds to any keyboard input. For example, I can use this device to play a game like Minecraft or any other game where only one hand needs to be on the keyboard. In theory, and with enough creativity, I can program this device to do pretty much anything a normal keyboard can. Obviously, this thing is by no means practical or useful. Nonetheless, it was fun to make and it's actually pretty simple at its core, so let's look at how it works. Let's first look at the microcontroller. The microcontroller I'm using is the ESP32 because it's cheap, fast, and simple to program. Any Arduino board would also theoretically work, but even the much more expensive Arduino Mega isn't as powerful as this thing. The microcontroller is electrically connected to 4 sensors, one for each finger. The sensors I'm using are the MPU 6050 because similarly, they are cheap, fast, and simple to use. These sensors record both acceleration and gyroscopic data, and this is what will be used to figure out what I was trying to type. The microcontroller records data from each sensor about 150 times a second, and when the acceleration of any of these sensors exceeds a specific threshold, the microcontroller recognizes this and assumes this was caused by a finger landing on the desk. When this happens, a set of samples spanning about 130 milliseconds is sent over to my computer. Right before the data is sent to my computer, it is packaged into a simple JSON format, containing the sensor's acceleration and gyroscope data at each point in time that the sensors were sampled. Ideally, this will be enough for an algorithm to effectively reconstruct the finger motion that happened during and just prior to the tap. Once this data arrives at my computer, we obviously need to examine it somehow to make an educated guess as to what this tap corresponds to. There are 2 ways I could think of to go about this. I could examine the data and manually code a statistical model using a technique like discriminant analysis, and then compare the inputted sample to some reference and make a best guess based on that. Or I could simply throw it into a neural network and let it figure everything out for me. You can probably guess what option I chose. This method does require me to train the neural network by recording some samples and telling it what each movement corresponds to, but within a few minutes of tapping, I'm able to get a model that's pretty darn accurate for most configurations. And that's basically it. To recap, data is collected by the microcontroller, and when a tap is detected, the last 130 milliseconds worth of data is sent over to my computer for a machine learning model to predict. Obviously, there's some complexity I'm skimming over for the sake of time, but it's really not too much more complicated than I'm making it out to be. I guess one last thing to mention are the rings I made to attach the sensor to my finger. It's a pretty basic design I made in Fusion 360, so there's really not too much to comment on here. I designed them such that they sit nicely on my fingers and hold the sensor in place. As I mentioned, you can configure this thing such that whatever movement corresponds to whatever key you want, so let's see that in action. Let's make it such that my computer scrolls up when I tap my hand like this, and scrolls down when I tap my hand like this. After defining a few things in the code, I can use a script that'll prompt me to perform the actions that correspond to the inputs a number of times in random order. Since this control scheme is so simple, 300 samples are probably more than enough to generate a model that can figure out this control scheme perfectly. And just like that, we have an awful scroll wheel. Before I end this video, I want to mention that the code is on GitHub if you wanted to construct this thing yourself for whatever reason. I will say that this code has not been rigorously tested, and some things I do are kind of hacky, so I'd highly recommend against using any part of this code in any device that actually needs to work reliably. Thanks for watching.